Chapter 30, Chemistry Theory Video 1. We are going to learn about chromatography. So this is something that we have touched at certain stages of our studies with regards to separation of materials and identification of different chemicals in a particular mixture. We know that we use chromatography. Now we are going to learn about this in detail and to identify what happens and how it is done. Chromatography, how it is done and what exactly happens in there. Now we have already learnt about paper chromatography. So there is a we use it to separate mixtures when solvent moves up a piece of absorbent paper. So depending on when you say that this is separation, you are actually don't think that it is we are going to like separate sodium chloride crystals from water. Not exactly like that. Here what we are trying to do is we are trying to identify whether it is present or not a physical separation per se. So then the solvent is called the mobile phase. And the water trapped between the cellulose fibers of the paper is called the stationary phase. So then the different substances that are going to be there in this mixture will have different affinities for the solvent and for the water. So when they move up, they actually have different rates at which they travel. So some would travel further up and the others would not travel that much, right? So that is what we need to understand. So here you can, as you can see, there is a there is a paper chromatography tank. This is the chromatogram that is produced is what we see in the second one. Then we compare the pure reference compounds so by calculating RF values, and we use those references and comparisons to identify what is there. The RF values, we call them retardation factors. They would be calculated and given, and then if the conditions are identical to those RF values, then we can identify for certainty we can identify what it is. That means the same temperature should be used and the same solvent should be used, and then we know how much it has traveled, etc. And by calculating the RF values, we can figure out what material it is, right? Then sometimes if there is a color, if the chemical contains a color, then obviously we can see it directly on the paper. But if it is not, we might have to use some chemical that would form color when it come into close contact with that particular chemical on the chromatogram. For example, they say that the amino acids will be shown as bluish spots when ninhydrin spray is sprayed onto that. Write down chromatography. In paper chromatography, mixture is separated when the solvent moves up the absorbent paper. The solvent is the mobile phase, and the water trapped between the cellulose fibers, stationary phase. Because the substances that makes up the mixture have different affinities for the solvent and water, they move at different rates. Right. So what it, in other words, what it means is, now if you have these pure reference substances, now for example, if you are checking whether there is an amino acid, so if you add amino acid, then it would move up to this point. So if in the mixture, if there is a dot here, then you can identify that there is a that amino acid is present in that. So then the same thing here, if if the chemical X is there, then if it travels up to this point, then you know, if there is a dot appearing here, then you know that it could be that particular chemical. I hope you understood. Then write down the RF values within brackets retardation factors would be calculated as shown below. With comparison to the values given, we will be able to identify what chemicals are present, but we need to make sure that the conditions are the same. Please draw this. This is how you calculate the RF value. RF value is the X upon Y. X is the the compound starting point to where it has stopped, that length, divided by the solvent front, the entire height. I hope you understood. Draw this, and then we will go to the next part. So we are going to discuss about partition coefficients in chromatography, and also please remember that this lesson is a highly theoretical lesson. That means you are going to get theory based questions from here. Now when we think about the principle of partition of solute between two solvents, so there are two solvents involved, and the partition of how do they get partitioned, then we actually understand how components in a mixture would get separated in chromatography. Now we have chemicals with different partition coefficients of the components that makes up this mixture, and then they will actually correspond to their relative solubilities in the two solvents. That means the chemicals that are present in the reaction mixture, or the mixture that we are going to check which substances are there, the different partition coefficients of those components will correspond to their relative solubilities in the two solvents. So there is a relationship between their solubility and the different partition coefficients of them. So we know that the mobile phase is the solvent that we choose. The other solvent is water trapped in paper structure. Then obviously that is the stationary phase. We have discussed that. Solvent is the mobile phase, then water is going to be the stationary phase. Where is this water? Water is trapped between the cellulose molecules in the paper. Now this figure, this 30.7 shows us how solute molecules are partitioned between the mobile phase and the stationary phase. So as you can see, there is a stationary liquid phase represented by the blue color. That is the stationary phase. Then there is a solid support on which this happens. Then solute molecules are able to solute molecules are dissolved in the stationary liquid phase, so they are able to move. Now the solutes in this mixture, they are separated and partitioned because of the between the solvent and the mobile, that is, solvent is a mobile phase and stationary phase. That means because of depending on the solubilities. If the relative solubility of this particular chemical is high in the mobile phase, that means it will pass over the stationary phase very quickly, right? So the mobile phase would pass over the stationary phase very quickly. So that means it would it would get carried a long way. I hope you understood. If you have any doubts, please ask me. Write down a note. In paper chromatography, different coefficients of the components in a mixture correspond to their relative solubilities in the two solvents. When the solutes in the mixture are separated and partitioned between the solvents in mobile and stationary phase. So in stationary phase, the solvent is water. If the relative solubility in the mobile phase is greater, the faster would be the rate of movement when mobile phase passes over the stationary phase. Please draw this and see if you can answer question number 1. If you have any doubts, please let me know.